So, we started with the nearest neighbor classifier in last class, okay. And then we talk about because this is a classification problem as usual. So, you need to do the identify the class level of an unknown object. As I said earlier also, unknown means that object is not in the training data set. So, what you have to do in case of the distance based classifier, you should have a notion of distance. So, you should able to compute the distance between two objects or two instances or two patterns. As you learned many distance measures earlier, okay, or similarity measure. So, one can choose any one of those measures and compute the distance or similarity measure. In case of the nearest neighbor classifier, the idea is very simple. What you have to do is from the unknown object to the all training data set, you have to compute distance, and you see the which point in the training data set is closest to the unknown object, okay. And you see the what is the class level of the closest object in the training data set, that will be the class level of the unknown object. So, in summary, you find the closest object of the unknown object in the training data set, and because it is a training data set, you know the class level of the each and every object, and so closest objects class level will be the class level of the unknown object. And then we say is what is the time complexity? Time complexity means you have to compute the distance from the unknown object. Let us say unknown object here is unknown object is the test pattern is x. You have to compute the distance from x to the all objects x dash belongs to the training data set. So, if the cardinality of the training data set is n, then complexity will be order of the n. And more specifically say let us say for computing distance, if the d is the dimension, okay, dimension of the each object, then complexity will be n into d order of n d, and because d is much smaller. So, this is lesser than the object here, what is that n. So, therefore, we consider the complexity will be order of n, and we are considering that we have to keep the entire data set in the main memory, that is why complexity is order of n also, time complex space complexity, but in fact, no need to keep the entire data set in the main memory, you can access the data from the secondary memory also. So, as you see this algorithm was proposed in 1967, but this algorithm has one severe drawback is like say we are talking about the closest object, but closest objects class level we are talking about what is that x is the unknown pattern, and you find that x dash in the training pattern, and you see the class level, what is the class level, that will be the class level of the object unknown object L. But what may happen, because this class level in many cases the class level is actually labeling is done by the human being. So, there may be a error, instead of say let us say class 1, if he writes the class 0, so then objects will be wrongly identified. So, training data set is like each object will have some label, but instead of writing 1, if someone writes 0, it is if it is a binary class classification, then that results is also wrong. Okay. So, therefore, if you rely only the closest neighbor, so this type of problem may happen. Okay. And maybe there are two closest objects. So, let us say this is x, another x dash and another is x double dash, they are very close to each other. So, but because this is closest one, we are considering only these objects here, but x dash and x double dash both are very close. So, to avoid this one, so after 10 years or I do not know exact timing. Okay. So, one algorithm was proposed is something called the k nearest neighbor classifier. So, it is a generalization of the earlier approach. In earlier approach, what we are seeing we are seeing the closest object. Instead of seeing the closest object, what we do it, you see the k closest object of the unknown pattern x. Okay. So, now earlier approach, what we can say, that is the 1 NN, 1 nearest neighbor. and this is we say is the k nearest neighbor. So, instead of saying the closest object, you see the k closest object. Okay. Then what you have to do? You have to compute the distance from the x to the all pattern in the training data set, and from here you find the k closest object. Now, you have the k closest object. Earlier what we are saying is what will be the class level of the unknown object? You see the class level of the closest object and then you find the class level. Now, you have the k objects. Okay. You have the k objects, let us say x dash is double dash and this triple dash and x quad. Okay. So, now you have the 4 closest object. What is the k value? Say k equal to 4. You can take k value anything 2, 3, 4, 5 and so on, but what will be the suitable value of k, that we will discuss little later. So, you assume k value. So, instead of taking the closest object, we will take the k closest object, and because you have the 4 objects here and each object will have class level. So, you see the class level, this is 0, this may be 1, this may be 0, this may be 1, or maybe this also may be 1. So, among the k closest object, you see the majority of the pattern belongs to, or majority of the objects belongs to which class. So, here if you see, if you take the majority voting, 3 objects belongs to same class. So, that is the class 1. So, therefore, unknown objects class level will be 1. So, instead of taking the k 1 nearest neighbor, you take the k closest object, and among the k closest object you take the majority voting on the class level. So, majority of the pattern belongs to which, if there is a tie, so you can choose any one of them, or you can, that classifier is unable to identify the class level. So, that is another option. So, if it is a 50-50, let classifier decide that whether you will classify as a class level or it cannot identify the class level. So, let us say pin code we write. So, someone write it this one. So, this may be 7, this may be 1 also. So, in that case, so machine can say is okay, this should be sorted manually. So, if there is a chance like is 50-50, so better classifier say is I cannot do it. Okay. There is another possibilities. Okay. So, now here in k nearest neighbor classifier, what we learn it here, we have to find the k closest object. Now, question is how do we find the k closest object of an unknown object? So, easiest way is you find the distance from the x to the all patterns, say x 1, x 2, x 3, x, these are all the pattern belong to the training data set. So, x 3, x 4 to x 100, and what you have to do, find the k closest object. So, you can sort them and then you take the say 4 pattern and you find the k closest, you find the class level. But what will be the complexity if I use this technique for identifying the class level of the one object? What will be the complexity? So, because you are doing sorting, so if there are n objects, so n log n, and then if you need to identify again m unknown objects, where m is order of n. Okay. So, then complexity will be n square log n, n log n into n log n square log n. But that is not the case. What we can do it, instead of n log n, we won't sort it, sort them. We can do in some other way for finding the k closest object of an unknown object. So, here is the algorithm. So, before telling this algorithm, so I move back and then I will describe it here, because we have a space here. So, what do we do it? We compute the distance. What is the objective? Objective to identify the k closest object of an unknown object. Let us say we have the pattern here x 1 to x 100, and this algorithm will be used in many applications. So, if you work in machine learning and its applied area, this algorithm frequently used, and this is very easy to understand this algorithm. It is very easy to implement also. Now, what is the advantage over this algorithm, or what is the disadvantage over the decision tree, I will tell little later. Now, we are talking about you have to identify the k closest object. or k nearest neighbor. So, of unknown object x, okay, that is the objective. And then earlier we say complexity was n log n. So, now what algorithm we will talk about, that algorithm has the complexity, it is not n log n, it is complexity is order of n. What we can do it? So, this is there are 100 objects. So, now what you do it, x is an object for which we need to identify the class level. So, what is the value of k? Let us say k equal to 5. So, and this is the set where we will store the all k nearest neighbor objects. So, 5 k closest point of the unknown object x. So, initially that k nearest neighbor set will contain the first 5 elements, let us say x 1, x 2, x 3, x 5. We consider these 5 are the k closest object of x, but this is not the final. So, this is the initial stage. Now, what you do it from the x 6 object onwards, I compute the distance from x to x 6, and if this distance is lesser than the distance of x to any point x belongs to k n n, then I will include the point x 6 in this set, and I will exclude the point which has the greater value than the x to x 6. So, what I said is there are 5 points here. Now, what I have to take a decision whether x 6 will be included in this k n n set or not. Please note that a k n n is like 5, k value is 5. So, in this set cannot be more than 5 elements. So, if I want to include the point x 6, so therefore, you have to exclude the some point from here. So, what is the criteria to exclude? The distance from the point x to x 6, this should be less than the distance from x to x 1 or x to x 2, x to x 3, x to x 5. Any one of the distance must be greater than the distance from x to x 6. Then only I can include this point into this set, and I can exclude some point, let us say x 2. So, now what we have to do it? I included the point x 6 and I remove the point x 2. Again you do the same thing for point x 7. You compute the distance from unknown objects x to x 7, and if this distance is lesser than the distance from any point from x to the existing k n n, so then this x 7 will be included, otherwise we cannot include the point x 7 here. So, then at each time what we are doing, we are computing distance from the x 6 to distance x, along with the we are computing distance from x to x 1, x 2, x 2 and so on. So, each time we are computing for deciding the fact that a point should be included in the k n n or not, we are computing how many distance? We are computing 6 distance. Distance from the point, that is the which point is the targeted point x 7, whether we can include the x 7 into the k n n set, that distance, and along with the distance from x to the all k n n. So, k n n value is k is very small. So, for each case, so there are n objects, it is already you have taken the k. So, there are object is n minus k, and each time how many distance you are computing? K plus 1 distance, each time you are computing k plus 1 distance. So, this is the complexity. So, if you see here k is small, as I said is k is 5, generally we do not see value k is 1000 or so on, even though so big data set also we do not see k is like 1 lakh or so on. So, therefore, we consider the k is very small. Ideally, for the smaller data set in general, say k value it does not exceed above 50. So, then k is literally very small value with compared to n, say n is like say 2 lakhs point or 2 lakhs object. So, therefore, everything is very small. So, then this can be considered as a n k. Someone also think of, say you compute the distance from x to the already k points, okay, and you can make a tree or heap tree or so. So, always the top point will be in the max heap, you can consider that one and you can replace this one. So, that will further reduce the point, instead of say k you can put log k. So, even the k is very small. So, we can consider the complexity will be order of n. No, there are two ways, as I said, is always you choose the maximum distance. If you sort it here, that is the point, this is also very small k. So, sorting will take k log k. Okay, you can sort them and you can pick the maximum distance point, but there is no way of there is no need for sorting also, because you need to replace the only one point whichever is greater than. Eventually, at the end data set is high, data set is large, eventually all points which are not the k closest point will be eliminated, and the only the k closest point will be there in the k nearest neighbor set. So, in Weka you can see there is something called lazy classifier. Okay. So, that is the k nearest neighbor classifier or nearest neighbor classifier with you can change the value of k equal to 1 means earlier approach. If you change equal to k equal to different value, so it will be the k nearest neighbor classifier. Now, question is why it is called lazy classifier. See, if you clearly there is a distinction between the earlier, that is decision tree, and this classifier. In earlier decision tree, you have the training data set and you made the model. Once model is built, then no need to take the concern with the training data set. So, you will work only with the model. Obviously, you need the test data set to verify the results, to evaluate the method. But in this approach, for identifying the class level, each time you have to trace the entire training data set. So, if the training data set is huge, so this will take the order of n is also a huge time compared to the if you go in the decision tree. Decision tree is, what is the complexity of the decision tree? Complexity of the decision tree is the depth or height of the decision tree. So, that is also a constant, like it may be say 20 or 30 depth, but that is also huge decision tree, and if you do not restrict the number of split. So, it is not a binary split. So, if you restrict the binary split, then also depth also will be 25 and so on. So, 25 depth means it will be 2 to the power 25, that many nodes can be accommodated. Okay. So, that means actually 2 to the power 20 means what? 1,000,000 nodes will be there. 1,000,000 nodes means you can think of the size of the entire training data set. So, therefore, even though and now you think that you have a training size of let us say in what is called is let us say in million, more than million. So, in that case what happened, the time complexity in case of the nearest neighbor and you compare the time complexity in the decision tree. So, it will be huge difference. So, that is why this classifier is something called is the lazy classifier. So, whenever object will come, then again you trace the entire training pattern and then only you can decide the class level. So, here is the complete algorithm here, k nearest neighbor classifier. Okay. So, what is this one? So, you have the training data set, this is the object and this is the class level as usual. What you have to do is task is remain same, that is you have to identify the class level of the unknown object, here x is the unknown object. Now, initially KNN value is null. So, there is no classifier. Okay. So, this is null, and then for each t in the training data set, what you have to do it, because x is the object and you have the training data set, what you have to do for each training data set, the if KNN value is less than equal to k. So, initially it was null. So, its value is cardinality is 0. So, it is less than k, then what you do it, that point you include into the KNN. Again you go, you include the next point here, because this value is still less than k, so let us k value is 10. So, you keep on adding the first 10 point, that is I said. First you consider the first 10 point is the probable k nearest neighbor. So, this is the set here. Now, if from the 11th point in the training data set, what do you do? Find a point in the KNN in this set such that distance of the x to x dash is greater than the distance from x to t. T is the now the new object. We need to decide whether that will be included in the training in the KNN set or not. So, that should be lesser than the distance from the unknown object x to the all object in the training data, each object in the KNN set. So, if anything is greater than, then we should include the point t here, but we have to exclude the point x dash. And if it does not satisfy, if you do not find this condition is getting satisfied, then no need to do anything. That means, if you find the new incoming points distance from the unknown object is greater than the all points in the KNN set, then obviously that cannot be the k closest point of the unknown object. So, therefore, we no need to do anything here. And at the end of the day, what you have to do? You have to find the class level. So, you got the 10 points or 11 points in the KNN set. Now, you see the each pattern's class level. That means, you aggregate the objects based on the class level. So, let us say out of the 10 KNN objects, 3 belongs to class A, 4 belongs to class B, and then 3 belongs to class C. So, then 4 pattern belongs to class B. So, then unknown object class level will be 4. So, you take the simply majority voting. So, then complexity for the single point it will be order of n, and for the n points it will be order of n square. So, one important thing, we are talking about the k nearest neighbor, right. So, you take the k value is not 1, you take the k value 2, 3, 4, 5, and I said also it cannot be beyond 50, okay, or I said is it cannot be beyond 1000 and so on, but what is the k value? As you see, it is very sensitive, because if you take the k value is 10 and there are 3 classifier, one example I showed you. So, 3 objects belongs to class A and 4 objects belongs to class B and another 3 objects belongs to class C, but majority of the pattern that is 4. So, 4 objects belongs to class B. So, therefore, I am saying the class level is. So, instead of taking the k objects, so if I consider the k equal to 10, k equal to 9, it may happen all are 3, then we cannot decide the class level. So, finding the k value is really challenging. Okay. So, there is no theoretical basis of finding the k value, but obviously, there is established empirical approach to find the value of the k. Okay. So, using cross validation technique. So, that is we will be discussing next. So, what is the cross validation technique? Let me introduce today for how do we find out. In the next class, I elaborate this one. Okay. How do you do it in theory lab class also I said, suppose you have a training data set here. As I said in a class also many times, so I repeat here. While building the model, you cannot use the information of the test data set, you can only use the information of the training data set. Whatever or wherever anything you can do over the training data set, not on the test data set. So, you have to keep test data set aside. Test data set only you can use whenever you are validating your model. How much good your model is, that will be decided by the test data set. So, now then first question, how to find the value of k, okay? Because finally, when you say this is my k nearest neighbor classifier, you have to say what is the value of k, and you have only the training data set. Using training data set, you are finding distance and many other things. So, ideally what is done is you have the training data set, you partition the training data set, disjoint partition you do into a number of folds. Let us say example 10 folds. So, this is something is block 1 or say let us say block 0, this is block 1 and so it is block 9, or you start from block 1 and then you end with block 10. This is something how many folds. So, if it is there are 10 blocks, so you are saying the 10 fold, as I said in the lab class also. If there are n blocks, that is something called one leave out method, because n blocks means each block consists only a single object, right. So, now I concentrate here, you have 10 blocks, out of these 10 block one block you consider as this is the test part. So, there are 100 objects. So, in block each block will have only 10 objects. So, you will get 90 objects for the training data set, and then all blocks here you consider the training data set and you make the model. But here we do not have like decision tree and so on. So, objective to find the value of k. What you do it? K equal to 1, k equal to 2, k equal to 3, k equal to 4 to k equal to 50. You find the class level of the each object in the test data set. So, and then what you do it? You find the how many times with the k value it can identify that out of the 10 objects, how many rightly classified with the k value equal to 1, with k value 2, with k value 3, k value 4 and so on for the one object, one block. Similarly, you consider the second block as the test and the others are training sample. So, then again you will get the 90 object for the training sample and 10 object for the test, but to avoid the term same term test here and test here, what we do it? We will say this test data set we will say is the validation set, we will say the validation set, and we will see for which value of k we are getting the least error. So, similarly, for each block will be the test data set or validation set, we will say validation set, and we find the error at the each value of k, wherever we are getting the value least. So, that will be the final k value. Ideally, we should get a plot like if you increase the value of k and if this is error, we will ideally get huge error first and then there will be a change of error and then again decreasing of the error. So, at this point this error is least and the value might be say let us say 22. So, then we have to take value of k equal to 22. So, I stop here. In the next day we start from the same slide here, and next class onwards I will complete the distance based classifier.